Some solving inequalities. We're actually going to do them algebraically and graphically, which you'll probably like graphically better because it's a little easier. Inequalities. You've solved inequalities before. You have? Yeah, it is. If you were going to solve it on a graph, it would be either number lines going one direction, or if it's a two-dimensional, it would be shading. So we're going to do a little introduction into interval notation. Interval notation. Okay. The book's answers are going to be in interval notation. Some people don't like interval notation. I like it. I don't know. I'll show you what it means. So if I say that negative 2 is less than x is less than or equal to 7. Okay? That's a compound inequality. It's an and statement. It means that x has to be greater than negative 2 and less than or equal to 7. And you could probably think of some numbers that fit the bill, right? You're probably thinking 0 or pi. No. Something like that, right? Now, in interval notation, this is not interval notation, but you can list your answers like this. I do not mind. The book will say that the answer is negative 2 to 7. Yeah. Note the difference. There's a parenthesis on one side and a bracket on the other side. So let's use some common sense or logic to figure out what that means. So the parenthesis means what? Not included, right? Not included. The negative 2 is not part of my answer. A bracket means that it is included because it's less than or equal to. Okay? So that's interval notation. It's pretty, yeah. People don't like it. I'll show you why people don't like it. Let's say that I have a number between 0 and 10. And if I were to write that in interval notation, you know what that looks like? It looks like a point. People don't like that because that's how he represents points, right? 0, 10. So, but I don't mind if I know that I'm asking for interval notation and you write it like that, I know you're not talking about a point. I know you're talking about from 0 to 10. So if you had something like x is greater than or equal to 3. You okay?
More than okay.
Good. All right, so interval notation for this, x is greater than or equal to 3, would be 3 all the way to infinity. And you never include infinity. Okay? Infinity never has a bracket on it. It's always a parenthesis.
Does it matter like the order?
It does. Order does matter. It's always smallest to biggest. Okay? Oh, sure. Sure. There you go. All right, smallest to biggest. So if I said x is less than negative 10. Okay, x is less than negative 10. If you think about a number line, and you think about numbers that are less than negative 10, let's say here's negative 10. It's an open circle, and it's all the stuff that way, right? But I need to write my interval in left to right. So I would start with negative infinity to negative 10.
So do you always write infinity when you have like one number? Like if it's
Yes, if it's one number, it's always going to have infinity. So if it's negative infinity, it's on the left. If it's positive infinity, it's on the right.
Wouldn't it be negative 9 since it's not equal to?
Well, okay, so what about negative 9.5? Negative 9.99999? You know, you have to go all the way up to negative 10, but not include it. So if you went, let's say if you went to negative 9 to here, well, you're missing an infinite amount of numbers. Teeny tiny little numbers, right? So if you go, okay, well, then let's go up to negative 9.999. Then you're still missing some numbers. So you have to say negative 10, but you don't include it. Right. So that's all the way up to negative 10.
And then so for the parentheses and brackets, it only gets a bracket if it's like less than
Or equal to. Yeah, so try this one. You try this one on your own. Let's say that x is less than or equal to 14. Let's write that in interval notation. Okay? Interval notation. X is less than or equal to 14. I'm not going to ding you, though. I'm not going to mark you off. If you prefer to write something like this, go ahead. But if the book does say write in interval notation, their answer will be in interval notation. So I'm just kind of giving you a heads up on that. So x is less than or equal to 14. This would be negative infinity to 14, like that. Yeah. No, you can't do that. 14 to negative infinity doesn't make sense.
Oh, it's less.
So if it's greater than, then your infinity is going to be on the other side. So if you had negative 3 is less than or equal to x is less than or equal to 17.
Why is it bracketed?
A bracket means that it's included. So if it has less than or equal to, it's a bracket. If it's just straight up just less than or greater than, it's a parenthesis.
Oh, so we'll get marked down if we don't use a bracket or not.
Oh yeah, because that makes a big difference. It would be like the difference between if you did an open circle on a graph or a closed circle on a graph. You know there's a difference between that. Yeah. If you say ages 12 and under, that includes 12-year-olds. If you say under 12, then that doesn't include 12-year-olds. They can't order off that little kid menu. Yeah.
So why is it negative infinity if they're positive numbers?
Okay, so this is all the numbers that are less than 14. Negative, all those negative numbers, all the way to negative infinity. Less than 14. So if you need to, you can always draw, a number line. And here's 14. And what are all the numbers less than or equal to 14? They go this way. So that would be negative infinity to 14. So what'd you get for this one? You got 2 brackets. Negative 3, comma 17. Those are easier, huh? Yeah. Mm-hmm.
Negative infinity applies anything under 14, right? Even if they're still positive.
Yeah, so if you're saying all the numbers from negative infinity, which is all the way down the number line,
Down that way.
yes, all the way up to 14. You're including everything from there. It's an infinite amount of stuff. All right, so you feel okay? Huh? How about the other way? What if I said if you had negative 6 to 1, and I want you to rewrite that in, I don't know, like with greater than or less than symbols, okay? Negative 6 to 1. This isn't even the lesson. This is getting you ready for the lesson.
Oh my God.
Yeah, this is just notation. We have a lot today. But I got you. I got you till whenever I got you.
Like, wait, so that's different
What is
from
the new
8:30,
time?
right?
What, 8:30? Yeah, 9:55. Woo, it's a long time. You're welcome.
Last year was like
Number 3?
On the PowerPoint.
Oh, I don't know yet.
It's right there in front of you.
Shh. Okay. Negative 6 is less than or equal to x is less than 1.
Yes.
Yay! Okay. See, it takes a little while to get used to it. Yeah, bracket and parentheses. How about one more, and then we'll move on to the actual lesson. Negative infinity to 0. Negative infinity to 0. What does that mean in greater than or less than symbols? So you're getting used to it already. Okay, or not. So it should be, never put a bracket around infinity or negative infinity. You cannot contain that. And then, oh, oops, sorry. Sorry about that. So then this would be, x would be less than 0.
Yeah.
Yes, okay. All right, let's move on, part B. It takes a little while for your brain to catch up. That's okay. We're going to do some absolute value inequalities now.
When will it fully count?
That depends on the person. Absolute value. All right, you did these in Algebra 2, but maybe you don't remember them, so here we go, because it was Chapter 1. It was a year ago, like next week. So let's go. Number 1. The absolute value of x minus 4 is less than 8. We're going to do this one both algebraically and graphically. I want to show you that you can do it 2 ways.
When you mean graphically, do you mean like on the paper?
On your calculator. What'd you say?
Oh, no, I said the graph is going to be in V.
Oh, yeah. The graph will be a V. Yep, absolute value. Good. Okay, so this one right here is telling me that this stuff right here has to be less than 8. Now, if I tell you can't walk more than 8 feet away from me, then you go that way 8 feet. Like if we're on a number line, you go that way 8 feet. Okay? Do you remember these?
Is this the shading?
No shading. We're not on a graph yet. We're just doing these. So that means that x minus 4 has to be between -8 and +8. If I tell my child, don't walk more than 8 feet away from me, that means he can go 8 feet that way or 8 feet that way. If we're on a number line, we're not in an open plane, we're just on a number line. And so you set it up like this. Do you remember this? This is less than, and it's an and statement, less than.
Why do you,
So then we're going to add 4.
for the -8, you just subtract 8 to the other side?
No, it's kind of like this, like the absolute value has to be less than 8. So the distance, absolute value is the distance really from 0, but this is less than 8, so it has to be less than 8 or greater than -8 or less than 8. It's contained between two things. So then you subtract, oopsie, don't like that at all. You add 4 to everything, and you get -4x 12. Okay, and that's your answer. Now, if you want to, the book will have this in interval notation, and so you want to say -4 to 12, like
This
that.
is the last lesson, right?
Yes, of chapter P.
Thank you.
Okay.
I swear.
Okay, let's go ahead and let's graph this now. So this is what I want you to graph. I want you to graph on your calculator y1 is the absolute value of x minus 4, and y2 is 8. Yes, absolute value is under math, num. Math, num.
Is math numbers this one?
Okay, so go to your calculator, and if you have your plots turned on, turn them off, and clear anything out. So we're going to go absolute value. So absolute value is found under the math button, math, num, and go to the right, and it's that first one, ABS. Absolute value of x minus 4, and then y2 is 8. And what you should get is a V shape, and a horizontal line. All right, so I need to widen my window a little bit, and I knew that because, x is -4 to 12. I kind of knew that was coming anyways. 32 would be a little overkill. We can go to maybe like 15. Okay, so change your window, -10 to 15, and then go ahead and regraph that.
What's it doing?
So now let's talk about what this is saying, okay?
Wait.
Yeah.
You're on 32 and it's fine.
That's fine. Yeah, 32 will be fine. So this is the graph. It's the absolute value has been shifted 4 to the right. And then I have this y equals 8 coming through.
You have to write that on paper.
No, I'm just going to explain it, and I can't really write on here. So, all right, so what this means is I'm trying to find out where my absolute value is less than 8. Where's my absolute value less than 8? Well, here's 8, and anywhere less than 8 is below that line, right? This absolute value is less than 8 when x is from here to there. And so what you can do is you can find those intersections. Calculate, intersect, number 5. Hit enter 3 times. So second trace, it's just like when we did intersections a couple days ago. And you get -4. And what do you think we're going to get over here? 12. We are. Okay?
What did you just do?
Yeah, you go to, remember we did this a couple days ago?
Yeah.
You go to second trace and then go to number 5, intersect, and hit enter 3 times. All right, so let's talk about this. This absolute value is above 8 in this red part. Okay? And then it dips below 8 in this yellow part. And whenever I have my answers, they're going to be intervals of x. I don't care what the y values are. There's no y in this problem at all, really. So from -4 to 12 is where my graph is below 8. That's algebraic. That's graphically done. Algebraically, you work through all the steps. Graphically, you graph and see where it's underneath 8. Yeah? No?
So how do you see the 12 part?
Then you have to do the intersection again.
Uh-huh.
So you go second trace, number 5, and then you want to arrow over to it.
Oh,
To-
to the other side?
Yeah, to the other side, just like we did the other day when we did intersections, and then it gives you x is 12. Okay? And that's graphically. Some people prefer that. Some people don't. Okay. All right, so let's do letter C now. So that was absolute value.
Oh, this is C already?
Absolute value, yeah. Well, maybe I should do another absolute value. What about greater than? Because we didn't do that.
I mean, I feel like I get the
I should probably do that one. You're right. Sorry, Kyle, or Ryan, you have to erase. I called you Kyle again. I should.
I wasn't paying attention.
Oh, good. Okay. All right, number 2. Let's do one that you have to do a greater than. So let's do 2x plus 1 is greater than or equal to 5. 2x plus 1 is greater than or equal to 5. So maybe I've had enough of my children, which, happens every day. And I say, you need to get 5 feet or more away from me, right? Terrible. What a great mom I am. So basically, they can go to here, and they go 5 feet that way, or they can go to here on a number line, -5 feet that way, okay? So what that means is this 2x plus 1 will be less than or equal to 5. So I go to -5, and I go the opposite direction. Or 2x plus 1 has to be greater than or equal to 5. Okay.
Oh, I forgot greater.
Greater than. Greater than 5 means I have to be a distance of more than 5 away. So if I go to 5 on the number line and I go more than 5, I go to -5, I go less than -5. Okay? And then you solve both of these. And it's an or statement in the middle because you can't be greater than 5 and less than -5. So let's go ahead and subtract 1. And then divide by 2. So x is going to be less than or equal to -3. Or subtract 1. X is going to be greater than or equal to 2. Okay, and you can leave it just like that. Let me show you the way that the book will write this, just so that you're aware, and it might look kind of weird. They'll write it as, so x is less than or equal to -3 would be -infinity to -3. And then they write this in the middle. It's a union symbol. Mm-hmm. 2 to infinity. Just so that you're aware and you get to that and you're like, what is that? That's a union. That means these work or those work. Okay? These are all answers. So anything from -infinity to -3 will work, and anything from 2 to infinity. So all the stuff in the middle doesn't. Oh, that one is really bad, huh? Thank you. Appreciate that.
Turn into 8s after a while.
Right? All right, so let's see what this looks like graphically. Okay? Let's see what this looks like graphically. Because I do, on Tuesday, I'm going to tell you right now, I give you the option. You can either do it algebraically or you can do it graphically. Okay, and I changed the test. And DK's not happy with me because he said it was so hard last year, and it was. And I made it a little bit easier. I've taken a couple problems off because it was way too long. And I made it all calculator.
You don't need to do that for us.
I do. Okay? 2x plus 1 and 5, right? Okay, so let's go ahead and graph that. There's the horizontal line, 5, and there's my absolute value symbol. Graphing is easier, right? Don't you love it? I know, it is. It's great.
Isn't this a whole non-calculator test?
Oh, no, I made the whole thing calculator now.
Oh.
Oh my goodness.
I did.
Holy smokes.
Even on the complex numbers part?
Yep. Mm-hmm.
What? Even on the complex?
Yeah. That's why we just did that thing today, because I took a bunch of these off.
People can just change to
Oh, that's why
change their
you
mode.
Yeah, I took a bunch of these off so that you're not even going to do these.
flipping over your
No. All right, here we go. So this one right here is a little different than the last one. This is, where is this absolute value greater than 5? It's greater than 5 here and here. Do you see that? And then it's below 5 down here underneath of it. So 5's our cutoff. This is our important line right here. And this one is, where is the absolute value greater than or equal to 5? So if you notice, from here all the way to this x value, and what do you think that x value is? We found it algebraically. It's -3. You can find it by doing the intersection on your calculator, okay? So where this green part is, right here, my absolute value is going to be greater than from -infinity to -3, and it's greater than or equal to, so I have to include that. And then once again over here, that is 2 if you find the intersection. I already know it because we did it algebraically. Then that would be up here above from 2 to infinity. Okay? Hardly any work algebraic or graphically, right? Yeah, it is easier, huh? All right, part C. We're ready?
I like that.
Yeah, me too. I'm glad we did that extra one. I'm glad you guys didn't talk me out of it. All right, quadratic inequalities now. Quadratics. Okay, it's going to be a lot like the ones we just did. Okay, those absolute value ones, it's just going to be a U shape instead of a V. So here we go. I'll show you how to do it algebraically, and then we'll do one graphically. What number are we on? 3? That's it? Number 3. Talking for 21 minutes.
Examples of intervals.
Yeah, that one took a long time. All right, x squared minus x minus 12 is greater than 0. So here's a parabola. I'm trying to find out where this parabola is greater than 0. So this is what you can do. This is algebraically how the book will show it and how you'll do it in like calculus and stuff. You want to start by factoring. Don't you just want to factor that? Don't you see it and you're like, ooh, that's factorable. I want to factor that. I know, right? So it's x minus 4 and x plus 3. Two numbers that multiply to give us negative 12 add up to negative 1. And so our key points are going to be 4 and negative 3. Now, there's a couple ways you can do this, okay? One is the book will say that you can go and you take negative 3 and positive 4. And those two numbers split up my number line into how many intervals? 3 intervals, right? 1, 2, 3. 3 intervals. And what I do is I need to test each interval to see if it's greater than 0. So pick any number between negative infinity and negative 3. What would you like to choose? Negative 4. Me too. Negative 6 works. Sure. Negative 10. Negative 100. Whatever you want. So take negative 4 and plug it into the factored one because it's just easier. You take negative 4 and you plug it into here. What do you get?
0.
No? That would be positive 4.
Oh, negative.
Negative 8. So you get a negative times a negative, which is a positive. Okay? So this interval has a positive, it's plus. It's more than 0. You don't even care what the number is. Now, pick a number between negative 3 and 4. How about 0? 0 is good, right? Let's pick 0 and let's plug in 0. When I plug in 0, I get negative 4 times positive 3. And what's a negative times a positive? It's a negative. And then finally, our last one, let's pick 5. Okay? And plug that in. Right into here again. And I get 5 minus 4 is a positive. 5 plus 3 is a positive. And a positive times a positive is a positive. All right, so let's answer the question. Where is this parabola greater than 0? Where are my positives at? That would be from negative infinity to negative 3. Okay, so this green interval, that's good. It's positive. I'm looking for greater than 0. And then this interval over here, which is from 4 to infinity. Okay, that's algebraically. Tricky, right? No brackets because this is strictly greater than.
Wait, can you explain the last part?
This part?
Yeah, just putting them into the...
Yeah, so our intervals are negative infinity to negative 3, negative 3 to 4, and 4 to infinity. And this one in the middle, it was less than, but we want only the ones that were greater than. So we want this interval from negative infinity to negative 3, not including negative 3, just greater than. And then we want the interval from 4 to infinity. Now let me show you this graphically, because you might like that better. Ryan hates this. Okay, so go to your calculator and graph it. Graph x squared minus x minus 12. I used to make kids do this by, like, with no calculator at all. And then they all got mad at me, and, you know, and then I thought, well, we have these calculators. They're pretty good. Let's use them. All right, and so here we go. We have our parabola. I'm going to hit zoom 6. Yeah, if you want to find the intersection, then you do need to put in y2 equals 0. Okay, so here it is. Here's my parabola. Okay. Here's my line y equals 0. So I'm trying to find out, this question's asking me, where is this parabola greater than 0? Greater than would be above 0. Okay? It's greater than 0, all these forever, and all these forever. And you know, with parabolas, it's going to be either the outside or the inside, right? Or, well, there's some special cases, but we don't get into that. All right, so then you want to find the intersection point, which, since we did it algebraically, we already know the intersection point. But let's do it. Calculate the intersection. Hit enter 3 times, and it finds x equals -3. Were you expecting that? Yeah, me too. And what are you expecting over here? +4. Okay? So where is this greater than 0? That would be from -infinity to -3, union 4 to infinity.
So for these, could we do algebraically and then check
Yeah, you could do them both. You could do one or the other. I kind of do a hybrid sometimes. Like, I'll do this, and I'll find out my zeros from factoring, and then I'll just draw a quick parabola. You know, that's pretty good, and then I can see where it's greater than. All right, let's do another one. Number 4. All right, how about 2x squared? Let's just do this one just graphically, okay? Plus 3x is less than or equal to 20. All right, so if I were you, or if I were me, if I'm trying to solve this, I would move that 20 to the other side. I'd start by doing that. Just so that I don't have to go all the way up to 20, you know, y equals 20. I don't want that. So I'm going to go 2x squared plus 3x minus 20 is less than or equal to 0. So go ahead and graph this one on your calculator. We're going to have to find the intersections this time, just because we're not doing it algebraically. This might not even be factorable. I don't know. It is? Bobby says it is, therefore it is. Plus 3x minus 20 and 0. Okay. And then graph. Okay. Now you can't see all of it, and it doesn't matter. You know it's a parabola. You know it's just dipping down real far. Okay? So it looks like this. You don't have to draw a picture of this. I'm just going to because I want to show you what we're looking for. So my key points, I need to find out where they intersect. Where those two graphs, y equals 0 and the parabola intersects. So I'm going to calculate the intersect, number 5. Hit enter 3 times, and I get 2.5. If you want to write 5 halves, you're more than welcome to. So at x equals 2.5 right here. Did anyone get the other one? -4? Okay, -4. Good, I don't want to waste my time. All right, so now let's answer the question. The question is, where is this parabola below or equal to 0? It's below or equal to 0 in this interval. And I kind of want you to think of that as a number line, not really like a graph of x and y. It's a number line, so the interval from -4 to 2.5. So in interval notation, I would write -4 to 2.5, and I would include those numbers. I include them because I'm looking where this graph is less than or equal to. They are equal to 0 at 4 and 2.5, and then it's less than all the points between that.
So since it's just that, like with the quadratic, we know to put brackets on both sides at all times?
No, if it's less than or equal to, it's the or equal to that makes the bracket.
Right. But
Mhm.
on both sides though?
Yeah, yep, it would be on both sides because it's equal to 0 here and here
Okay.
because of quadratic, yeah.
And then if it's not, then it's still that.
Yeah. Okay, let's do one more, and this one is actually not a quadratic. It's a cubic.
Oh what?
Cubic.
Ew.
Oh my gosh.
x cubed,
And you said there was a D, right?
yeah, plus 2x squared minus 1 is greater than or equal to 0. I'll give you a little break. We'll take a little time out. Put you in time out before the last part, because the last part's pretty intense. I know, it's like when I'm working out and the girl's like, here's our worst circuit yet. And I'm like, dang it. Yeah, I hate that. I'm like, please don't tell me that. We're going to do 40 burpees in a row. Like, I'm out. No, we did burpees for 30 seconds. It wasn't that bad. Okay. X to the third plus 2x squared minus 1 and 0. All right. Graph that. Let's see what this one looks like. Ooh.
Damn.
I'm going to need to zoom in, I think. Oh, sorry. X cubed plus 2x squared minus 1. I'm going to zoom in a little bit because I'm not sure what's going on at that, right there at that x-axis. So I'm going to go to zoom and hit zoom in and then hit enter so that it actually zooms in. Oh, I thought so. It was sneaky. I thought it dipped up. Did you?
Yeah, I did that. Wait, that little thing's a dip up?
Oh, yeah, that thing's a total dip up.
No, whatever that means.
All right, so here we go. Let's take a look. It dips up, comes down, goes through. Yeah, okay, so I hit zoom 6, made a basic window. Well, zoom 6, I couldn't tell. I was like, wait a minute, what's going on right there? So then I went to zoom in, which is number 2. Zoom in. I hit enter, and then I hit enter one more time, and it actually zoom in for you. So you don't have to change the window, or you could change it manually. But I like zoom in. Sometimes it works. Okay, so where is this guy greater than or equal to 0? This one is greater than or equal to 0 here and here. Okay? So basically I need to find out what this interval of x is and what that interval of x is. There's 2 parts, right? Where is this thing greater than or equal to 0? In the blue sections, so on my number line, it'll be those. So I need to find all 3 intersections. Yep. So calculate the intersect. And they're going to be ugly, and that's okay. Just round to 2 decimal places. 0.62. And then we got to find the next one. You're getting real good at this. And we get, ooh, -1. That's lovely. And one more. Did you get the last one? There's 3. So there's 1, 2, 3. And it's a cubic, so I was kind of thinking there might be 3. -1.62. All right, once you have those 3 numbers, we're ready to set up our intervals. Okay? So here we go. Our answer is going to be greater than or equal to. So any number I have, I want to have a bracket there. So in this interval right here, I'm going to call this the yellow interval. My answer would be -1.62 to -1. Always the smaller number to the bigger number. Okay? And then union, and then I want this green interval over here, because that's where it's above. And that interval would be from 0.62 to infinity. So much better graphically than algebraically, especially that one. Any questions on that? This is hard. I know you did not do this last year. And this is in the prerequisites chapter. So, all right, we've done 34. Last part. Oop, last part. All right, who are my physics people out there? We got any physics people? Yes. All right, we're going to talk about projectile motion.
Whoa. Projectile protection.
Projectile motion. Projectile motion. Yeah. Thank you. All right, projectile motion. Here we go. It says here.
Wait, projective or projectile?
Projectile. Oh.
That says projective.
Whoopsies.
What is that?
I don't have it. Oh,
That's an L. Projectile motion. Sorry.
Oh.
Projectile motion. Yep.
You just took the L.
It's the movement of an object that's propelled vertically, but it's subject to the force of gravity only. Okay. Here we go. So here's the equation for projectile motion. S equals negative 16 t squared plus v sub 0 t plus s sub 0. It's okay. It's okay. I'm going to explain it all. I'll explain it all. Don't you worry. Okay. S equals negative 16 t squared plus v sub 0 t plus s sub 0. I know it's a little sub 0. I wrote it a little bit big. S sub 0. Okay, can you guys be quiet so I can do this? That'd be great. All right, here we go. So S is going to stand for, and do they have it in a certain thing? It's going to be in feet, okay? It's the vertical position of it's like the y value. Vertical position of the object in feet. In feet. I know. You can also have this in meters, which would be negative 9.8 t squared, but we're going to stick with negative 16. Nope. All right, so then t is going to be our time in seconds. It's like the x value, time in seconds. Okay? Now, what is this v sub 0 and this s sub 0? V sub 0, is your, anything that's a sub 0, s sub 0, v sub 0, that's going to be your initial velocity. It's the velocity that it's starting at, because the velocity does change when the object, right? If it reaches the top, what's the velocity? 0. And then s sub 0 is going to stand for just the feet above ground. It's your initial vertical position, feet above ground. Okay, now that you know all that, this will be given to you, this equation right here will be given to you on your test.
You can make it out.
But then we have to figure out the rest of it. Yeah.
So is that V or V0?
It's v sub 0, so it should look like that, like a subscript.
It won't tell us what the dates are?
No.
We're that lucky.
All right, number 6. Here we go. I'm just going to do one of these, but it has a couple parts to it. It says here, a projectile is launched straight up from the ground. Okay, so projectile, maybe it's a rocket or something. Sometimes a golf ball, you can hit that straight up from the ground. If you're lying in the fairway or whatever. Projectile is launched straight up from the ground. Can you stop talking for like the next 5 minutes and then we'll be good? Launched from the ground. That says launched. It doesn't really, but it does. It's supposed to. Launched from the ground, okay, with an initial velocity of 288 feet per second. Okay. So picture this. Here we are. Time is 0, right? Our initial time is 0, and something is projectile launched like this, and it's going to hit the ground. Okay? All right, and the initial velocity is 288 feet per second. That's just how fast it's going. Velocity is like speed, but velocity can be negative. Yeah. So all you physics people out there, you love it. Now, here are the questions. Letter A. When will the projectile's height above ground be 1,152 feet? So when will the height be 1,152 feet? Now, you are allowed to use your calculator on this, of course. These are some big numbers. You're allowed to graph it. You're allowed to do it algebraically, whichever way you want to do this, okay? So let's go ahead and plug in all the information that we have into our original equation that I gave you, that S equation. So S equals negative 16t squared. That does not change.
So it'll always be negative.
Yeah. As long as we're in feet, it's negative 16. Plus v sub 0. Now, v sub 0, they gave to us the initial velocity was 288 t, and then it's off the ground, or it's on the ground, so s sub 0 would be 0. Yep. S sub 0 stands for the feet above the ground, because sometimes we're like, I'm 5'7" and I'm launching a, some kind of an arrow. Yes, there we go. All right, so there's our equation. And now what we're going to do is we're going to find out when the height is 1152. So we're going to plug in S equals 1152. Okay? How long does it take to get to 1152? So go ahead and plug that in for S. And what I would do really is, let's plug that in. 1152 equals, bless you, negative 16t squared plus 288t. And I would move that 1152 over to the other side. Okay? So I would get 0 equals negative 16t squared plus 288t minus 1152. You can do a couple of things here. You can try and factor it. It's actually factorable. You can factor out a negative 16 and then factor it. But I'm not going to do that. Or you can graph it. And I'm going to go ahead and graph it. Okay? And I wanted it to stay negative because I want it to be that shape of an upside-down parabola, not to mess with the problem. So let's graph this thing. We're going to need to change our window big time. Okay? Yeah, so here we go. So let's go negative 16. Make sure you use the negative button, not the minus. X squared plus 288x minus 1152. Now, go to, and then have y equals 0 in there. That's fine for y2. Go to window, and we're going to figure out a correct window to use. I'm going to go, since x is time, I'm going to go from 0 seconds to, I don't know how long this might take, maybe 20 seconds in the air. I'm not sure. Okay, I'm not positive. And then my y min, I'm going to go from 0, okay? And then I need to go past 1152. I'm not sure how far I need to go. Maybe 2,000, maybe more. I don't know. So let's try. Do you want to try 2,500? 2,000 worked? Oh, okay. It's small. Oh, so we should go below that then, huh?
Below?
Holy smokes, that thing. No, just zoom in.
Did I do it wrong?
Click zoom in.
Mine looks just like yours.
0. Yeah. Oh, I started it at, no, I started at 0.
You started at 2,000.
Mine's
Yours
weird
is?
and tiny.
Yeah, it's fine.
It's tiny.
Is this supposed to
Maybe I shouldn't have had that. Maybe I should do that. Yeah, you know what? Let's do that instead. Let's take this and move it back over. I don't like that. And let's put 1152 in for y2. And let's change this just to that for y1. I think that would be better because then we can actually see the motion. Do you see what I mean?
So just
Okay.
leave it how it was.
Yeah. Just do it back to the original. I was trying to be fancy. So let's go ahead and delete.
Just cross.
And then let's put in 1152.
Yeah, that works better.
Does that work better?
A lot better.
A lot better. Oh, good. Yeah.
Oh, 32.
Okay, that looks more like the projectile, and then I need to adjust this a little bit, right?
32.
So
No,
20's fine.
No, I bet you 32.
Y max, what'd you go up to? 2,000, and it worked
I
great.
just left mine.
Oh, you left it. Good.
Yeah.
I changed mine on accident. Ooh, that's good. Okay, much better. All right. So here's what the graph looks like. We're down here at 0. Here's our projectile motion. We want to find out at what time do we get to a height of 1152. It actually happens twice, right? Happens on the way up, and then it happens on the way back down. So we find the intersection. Calculate. Intersect, and it's going to be beautiful. 12. They don't, though. And then calculate the intersection. What did you get the other one? 6. Perfect. 6. Okay, so then the question they're going to ask will be, when will the projectile's height above ground be 1152? So you would need both answers, okay? So you would say at t equals 6 seconds and 12 seconds. And because we're hitting this from the ground, it is symmetric. That's why you get 6 and 12. Do you know where it's going to hit the ground just by knowing that it's symmetric? Anybody want to guess? 18. From here to here is 6. So from there to there is going to be 6. And 6 more than 12 would be 18. Oh, in the middle. Yeah, in the middle. Oh, when it reaches the biggest height. Yeah, that's a good question too. Now the next question they're going to ask is, here's how it relates to today, to our lesson today. When will the height above ground, so when will the height above ground, last question, there is an end, be at least 1152. Okay, here's where our intervals come in. At least 1152 feet. So when's the height above ground going to be at least 1152 feet? So they would say, and I don't mind however way you want to write this, okay? The book says that the answer could be from t would have to be greater than or equal to 6, and t would be less than or equal to 12. You can write it like that. You can write 6 to 12. Now, at least means including, right? It's including 1152. You can, if you are so comfortable and you like that interval notation, you can write it just like that. Now, if they say, when is the height greater than 1152, that would change a little bit, right? At least 1152 means 1152 and higher. Greater than 1152 would be what? 6 to 12 with parentheses, okay? Because at 6, it's 1152. So above that would be from 6 to 12. And that's it.